reaction. Suppose an object is placed on table surface like this, right? Okay. The weight of the body is acting on the surface. The surface will act a force and turn in the opposite direction. This is what is called normal reaction. So when any body, when it is kept on the surface of another body, the surface in which it is kept will act a force on the body normal to the surface of the body. That means that reaction force is acting normal to the surface. That is why it is called normal reaction. Normal reaction is a reacting force acted by the surface on which the body is placed, but that normal reaction will be perpendicular surface. Suppose that it is the case. Suppose the surface is inclined plane. What is an inclined plane? A plane which is making angle theta with the horizontal is called inclined plane. Now suppose that the body is placed here like this. Suppose a body is placed here like this. Okay. Then in this case, W and R are in the same line, but in this case it is different. As it is the this is acting vertically downward. This is W. W is equal to mg. You will say that is W means most of the time it is gravity force. It is called W is equal to mg is acting like this, right? Okay. Now the force of reaction, that means normal reaction, is acting along this. This is called a normal reaction. So normal reaction is a reacting force acting normal to the surface on the body. It is acting on the body, but is acting on the acting as a normal to the surface on which it is placed. That is why it is called normal reaction. In this case, W and R are in the same direction, but in this case, W and R are not in the same direction. Am I correct? This is the condition you have to apply, right? And because in this case, after some time, you will see that suppose this is mg, this is equal to mg cos theta. If this is theta, this also will be theta. Mg cos theta. Mg cos theta will be in the direction of r. But in this case, what? R is equal to r. When it falls down and become plane, then this will be the condition. Suppose this is consisting of two layers. Two layers when falls down, then this is the situation. When one layer is taken up, then this is the situation, right? So when it falls down, gradually theta decreases, and mg cos theta becomes equally mg cos 0. Mg cos 0 is mg only, then that is W. It is the only thing, very simple thing it is to understand. So now when the inclined plane, it is a normal reaction. I am going to tell you what is called normal reaction. So this is what is called. So when the normal reaction is fixed, limiting friction does not depend on the area, does not depend on the area of contact or shape of the surface. The force of friction does not depend on the area of contact and the shape of the surfaces, only if the normal reaction remains a constant. If the normal reaction is not a constant, then force of friction may be depending on the shape of the body and also the total area of contact between the two surfaces. This is another most important thing. The last point I want to tell is that the magnitude of the limiting friction, that means Fs is directly proportional to normal reaction. You know what is normal reaction, right? Last point, what is that? The force of friction is directly proportional to normal reaction. So this is the point number 4. So all these points you will remember, see the recorded video again and again. It is your property. Many times you can see that. That's the advantages of this kind of recorded videos. Many times you can repeatedly you can see these videos, right? So what's the last law of friction? That is the force of limiting friction, or Fs, or simply static friction, Fs, is directly proportional normal reaction. So that is the last 4th law. Fs is directly proportional to normal reaction, or Fs is anything is proportional to the other, then we can say that Fs is equal to a constant of mu s into R, we can say, where mu s is a constant proportionality called coefficient of friction, where mu s is equal to coefficient of friction. Coefficient of friction is called, right? Or coefficient of friction mu s is equal to mu S is equal to, that is what is what? F is divided by R. So this is a very famous relation related to friction, right? Mu is what is called coefficient of friction between two bodies. That's a constant. So it is a ratio, pure ratio it is called. Therefore, coefficient of friction has no unit, and hence it has no dimension, because this is force of friction is also a force only, and a reaction is also force only. Units cancels, dimension also cancels. That is, and also it is a ratio of two similar quantities, so it is called a pure ratio. Am I correct? This is what is called the laws of friction. So laws of friction, number one, number two, number three, all this and also number four. But the fourth one is more important. So according to the main law, main very important law of friction, what you say? This is the force of limiting friction is directly proportional normal reaction. Therefore, force of friction is equal to a constant mu is into R, where mu is called the coefficient of friction, right? So this is something about a static friction. Now we are coming to the kinetic friction. So static friction, we have talked much about that. Now we are coming to dynamic friction. Dynamic friction means when a body moves over the surface of another body, then the force of friction acting between these two surfaces is called dynamic friction. One body must move over the other. One body is fixed, other body is moving, right? Yeah, both the bodies are moving. Then also there can be force of friction will be acting between them. This is called a kinetic friction. Kinetic friction is denoted by what is called a small f and a k at the right bottom corner. This is what is called Fk. That also same thing. That means when a body moves on the surface of another body, that means when the body is executing a motion on the surface of the body, the force of friction acting between these two bodies called the kinetic friction. Always kinetic friction is also acting in a direction opposite the direction of the body, right? And also the other two laws are applicable here also. What is that? That depends on the nature of the two surfaces. That also same thing. That means if the normal reaction is fixed, the kinetic friction does not depend on the nature of does not depend on the area of contact or the shape or size of the surface, right? This is the condition. Last one is again important. The force of kinetic friction is directly proportional to normal reaction. That is again same thing only. Force of kinetic friction is directly proportional to normal reaction is most of the time denoted by the letter R, right? But Fk is directly proportional to R. Therefore, Fk is equal to a constant mu k into R, where mu k is called coefficient of kinetic friction. The other one was coefficient of static friction. This is coefficient of kinetic friction. Coefficient, coefficient of kinetic friction. Kinetic friction is called. Or we can write mu k is equal to Fk divided by R. This is what you call kinetic friction, and also the laws of kinetic friction. All the conditions are same only. Most of the wordings are also same only. So always the frictional force is acting in a direction opposite direction of motion of the body, and also the force of kinetic friction on outside. Okay. Next, next is what is called angle of friction. What do you understand by angle of friction? Angle of friction, we will say. Next topic is what? Angle of friction. Angle of friction. You suppose that a body is kept on a table surface. This is a table surface here like this, right? Okay. These are the two. legs on the table is right, kept, okay, and the body is kept on the table. It is like this. A body is kept on the table. Yes, it is like this. Okay, this is the function, right? Am I correct? The body is pulled. That means it is, suppose this is central point, it is pulled by a force in this direction, right? So when the body is pulled in this direction, the body will tend to move in the direction of the external force. This is the external force, right? Therefore, force of friction will be in